Hello, welcome to MasterClass in Algebra for JSS1 to SS3. Lesson 3, Factorization. Today we are going to focus on common factors and grouping of algebraic expressions. By the end of this lesson, students should be able to explain the meaning of factorization, number one. Number two, students should be able to identify common factors in algebraic expressions. Number three, by the end of the lesson, students should be able to factorize expressions using the highest common factors, HCF. And number four, students should be able to factorize expressions containing numerical and algebraic factors by the end of the lesson. And lastly, number five, students should be able to factorize expressions by grouping by the end of this lesson. Before we go into the lesson proper, let's try our hands on this starter. Recall that in multiplication, 6 multiplied by 4 is equal to 24. Now, therefore, 6 and 4 are factors of 24. So the number 6 and the number 4 are factors of 24. So what is a factor? In mathematics, the factor of a number is that number that can divide a particular number without remainder. In this instance, the factors 6 and 4 are numbers that can divide 24 without remainder. So because 6 can divide 24 without remainder, 6 is a factor of 24. Because 4 can divide 24 without remainder, 4 is also a factor of 24. Similarly, when you have an expression like this, 3 multiplied by bracket open x plus 5 bracket close. This expression can be expressed as 3x plus 15. In other words, if the bracket is removed, if we expand this expression here, the result is going to be 3x plus 15. And how do we do that? How do we expand this expression? By multiplying everything inside the bracket with 3. So if we use 3 to multiply everything in the bracket, the result is going to be 3x plus 15. Now take note that the number 3 and the algebraic expression x plus 5 are factors of 3x plus 15. So the number 3 in this example and the expression x plus 5 are factors of this algebraic expression 3x plus 15. Why are they factors of 3x plus 15? And the reason why they are factors of 3x plus 15 is because if you divide 3x plus 15 with the number 3, the number 3 will divide 3x plus 15 without remainder. The algebraic expression x plus 5 can also divide 3x plus 15 without remainder. Therefore, these two values, 3 and x plus 5, are factors of the expression 3x plus 15. So when you get to this point in the video, I want you to try this exercise. Now pause the video and do this exercise. Identify two factors of 20, 36, 6x, and 8x. Pause the video and do the exercise. Or pause the video and do the activity. When you get to this point in the video, I want you to pause the... When you get to this point in the video, I want you to pause. When you get to this point in the video, when you get to this point in the video, I want you to pause the video and try these activities. So you are going to identify two factors of number one, 20, number two, 36, number three, 6x, and number four, 8x. So quickly before we proceed, two factors of 20 are 4 and 5. 4 can divide 20 without remainder, therefore it's a factor of 20. 5 can divide 20 without remainder, therefore it's a factor of 20. Two factors of 36 are 3 and 12. 3 can divide 36 without remainder. 3 into 36 is 12. 12 can divide 36 without remainder. 12 into 36 is 3. Therefore, 3 and 12 are factors of 36. Factorization is a process of writing an algebraic expression as a product of two or more factors. So let's look at this example. 3 multiplied by x plus 4 is equal to 3x plus 12. So if we have this expression originally, let's say 3x plus 12, let's say you are given this algebraic expression and you are asked to factorize it. Now, the factors of 3x plus 12, or the factorized version of 3x plus 12, is going to be 3x plus 12 is equal to 3 multiplied by x plus 4. So according to the definition, it is a process of writing an algebraic expression as a product of two or more factors. Now, so this expression 3x plus 12 is a product of 3 and x plus 4. Therefore, 3 and x plus 4 are the factors of the algebraic expression 3x plus 12. Therefore, if you are given this expression 3x plus 12 and you are asked to factorize it, what you do is to express 3x plus 4 as 3 multiplied by x plus 4. This is the factorized version of this expression. So it simply means expressing the original expression as a product of two or more factors. That's what factorization means. And factorization is a reverse of expansion. So what does that mean? That means that we can also express 3x plus 4 as 3x plus 12. In other words, if we expand the value 3x plus 4 by removing the brackets, we are going to get this value 3x plus 12. So when you reverse expansion, you get factorized version of an expression. When you reverse the factorized version, you get the expanded version of an expression. I hope that's clear. Previously, in the previous slide, we looked at factors of an algebraic expression and factors of numbers. Now, in this section, we are going to look at common factors. Now, what are common factors? Common factor, or a common factor, is a factor that occurs in every term of an expression. A factor that occurs in every term of an expression. So what does that mean? Now, this is an expression, 6x plus 12. And this expression is made up of two terms. You have the algebraic expression 6x and you have the constant 12. So a common factor of 6x plus 12 is going to be a number that occurs in both terms. So a number that occurs in 6x and as well occurs in 12. So that number will be the common factor of 6x plus 12. So how do we go about finding the factors of 6x plus 12? So let's do it this way. So what are the factors of 6? So first thing we need to do, we need to look for the factors of 6. What are the factors of 6? The factors of 6 are any number that can divide 6 without remainder. So 1 can divide 6 without remainder, 2 can divide 6 without remainder, 3 can divide 6 without remainder, 6 can divide 6 without remainder, 4 can divide 6 with remainder, 5 can divide 6 with remainder. But 1, 2, 3, and 6 can divide 6 without remainder. The factors of 12 are 1 can divide 12 without remainder, 2 can divide 12 without remainder, 3 can divide 12 without remainder, 4 can divide 12 without remainder, and 6 can also divide 12 without remainder. So how do we get the common factor, that is the number that can divide the two terms in this algebraic expression without remainder? So we are going to consider these two factors of 6 and 12. Now if you look at it carefully, you'll discover that what are the common factors here? The common factors are 1, 3, and 6, right? So what do we do? So if we are asked to simplify this expression, 6x plus 12, for example, so it is correct for us to express it as 6 multiplied by x plus 2. So this is a simplified version of 6x plus 12. Now you can see that we have been able to express 6x plus 12 as a product of 6 and x plus 2. What's the meaning of product? Product simply means multiplication. I know I've been using that word since. So it means multiplication. So we have been able to express 6 as a product of, we have been able to express 6x plus 12 as a product of 6 and x plus 2. That is, we have been able to express it as 6 multiplied by x plus 2. So if we use 6 to multiply everything in this bracket, we are going to get back 6x plus 12. So this is how you factorize an algebraic expression. So if you are asked, you are given an expression 6x plus 12, and they say factorize that expression. So what do? You look for the common factor. And what is the common factor? A number that can divide 6x without remainder and can also divide 12x without remainder. You use that number and then you express the expression as a product of its factors. So this is the factorized version of 6x plus 2. Now somebody will ask, 2 is a common factor. 3 is also a common factor. So can't this value 6x plus 12 be expressed as, let's say 2 multiplied by 3x plus 6? Because this value will still give us 6x plus 12. Can you see it? Now it is possible for us to express it as 6 multiplied by 3x plus 6. We can also express it as 3 multiplied by 2x plus 2. 3 multiplied by 2x is going to give us 6x. 3 multiplied by 4, this should be 4. 3 multiplied by 4 will give us 12. So it is possible for us to do that. But I want you to look at these three factorized versions of 6x plus 12. Look at the three of them. Look at them closely. Now you can see that the simplest version is 6 multiplied by x plus 2. This version can be simplified more than this. This version can also be simplified more than this. But this version, 6 multiplied by x plus 12, can't be simplified more than this. Therefore, this is the correct answer. So when you are asked to factorize an expression, you factorize it to its simplest version, in its simplest form. So that's what you're expected to do. So let's look at some examples on how to factorize an algebraic expression. So we're going to start with factorization by taking out the highest common factor. In the last example that I did, I used the highest common factor of the algebraic expression. So in this example, we're going to see more on how to use the highest common factor of the algebraic expression. So example 1, factorize 8x plus 12. So what are we going to do here? First of all, we are going to write out the factors of 8 and the factors of 12. So the factors of 8 are 1, 2, and 4. 1, 2, and 4. So if I may ask, why is the number 1, 2, and 4 factors of 8? 1, 2, and 4 are factors of 8 because they are numbers that can divide 8 without any remainder. So that's why they are factors of 8. Factors of 12 are also numbers that can divide 12 without remainder. And they are 1, 2, 3, and 4, and 6. Okay? So remember, according to the subtopic, we are factorizing by taking out the highest common factor like we did in the previous example. So if you compare the two numbers, the factors of 8 and the factors of 12, you will discover that the highest common factor, that is the factor that is common to both numbers, is 4. 4 is the factor or the number that is common to 8 and 12. And also, it is the highest common factor, right? So we are going to use this. The reason why we're using the highest common factor, let me explain that. The reason why we're using the highest common factor is because this is the factor that will give us the simplest version of 8x plus 12 when we factorize it. Okay? Therefore, 8x plus 12 can be expressed as 4 multiplied by 2x plus 3. Now watch closely. So how did I get 2x plus 3? Here, I have expressed 8x plus 12 as a product. Remember I said product is multiplication. As a product of 4 and 2x plus 3. So how did I get 2x plus 3? Alright? So 2x plus 3 is also a factor of 8x plus 12. So if I use 4 to multiply 2x plus 3, I'm going to get back 8x plus 12. 4 multiplied by 2x is 8x, and 4 multiplied by 3 is 12. Let me look for a simpler way to explain this. Alright, now let's look at it this way. We have a common factor of 4, right? Okay, so I'm going to use 4 to divide 8x plus 12. So let's say 4 divided by 8x plus 12. So 4 divided by 8x is going to give us 2x. Plus 4 divided by 12 is going to give us 3. So we are going to take this as a factor of 8x plus 12. And we're also going to take 4 as a factor of 8x plus 12. So to express 8x plus 12 in its factorized form, it means that we are going to find the product of 4 and 2x plus 3, which is this. 4 multiplied by 2x plus 3 is going to give us back 8x plus 12. I hope you understand it. Example 2. Let's look at this other example. Here, we're asked to factorize 15x plus 20. So once again, I'm going to explain. So when you have this type of question where you're asked to factorize an algebraic expression, in this instance, 15x plus 20, what it means is that you are to express 15x plus 20 as a product of the factor of 15x plus 20. So when you are given an expression like this, factorize 15x plus 20, the first step you need to take is to find the factors of 15x plus 20. So when you now have the factors of 15x plus 20, you now express them as a product. In other words, you multiply them together. Okay, so the first thing we need to do if we want to do that, we look for the factors of 15. What are the factors of 15? The factors of 15 are 3 and 5. Or let's start from the beginning. Let's say 1, 3, and 5. So once again, I'm going to ask the question, why is 3, 1, 3, and 5 factors of 15? The reason why they are factors of 15 is because they are numbers that can divide 15 without remainder. Therefore, they are factors of 15. So what are the factors of 20? The factors of 20 are 2, 4, 5, and even 10. 10 is a factor of 20 because 2 times 10 is 20. 5 times 4 is 20. 4 times 5 is 20. 2 times 10 is 20. So these are factors of 20 because they are numbers that can divide 20 without remainder. So take note of that. So the next thing we are going to do, because we are factorizing by taking out the highest common factor, the HCF. So the next thing we are going to do, we are going to consider the factors. We are going to consider the factors of 15 and 20. We are going to look at them. Now, we look at the factors and then we pick out the number that is common to both 15 and 20. In other words, we pick out the highest number that is common to both 15 and 20. The highest number that is common to 15 and 20. That is what we are looking for. So after expressing the two numbers like this, after writing out their factors, we will now look for the highest number that is common to both of them. And the highest number that is common to both of them is 5. So 5 is the highest number. So what next do we do? The next thing we have to do is to write out our 15x plus 20 and then divide this value by 5, which is a common factor or the highest common factor. We use it to divide this value. So 15x divided by 5 is 3x and 20 divided by 5 is 4. So what have we done? We have successfully divided or shared 15x plus 20 into two parts. This is the first part and this is the second part. So now, to factorize the value 15x plus 20, what it means is that we should now write 15x plus 20 as a product of 5 and 3x plus 4. So this is the factorized version of 15x plus 20. Example 3. We are asked to factorize 12x plus 8. So what do we do in this instance? So I want you to pause the video and attempt this. So do it before I try it myself. Okay. So 12x plus 8. Factorize 12x plus 8. So I said what you do, first of all, you express 12, or you write out the factors of 12. Here we have 1, 3, and 4. 1, 2, 3, and 4. These are the factors of 12. Factors of 8. The factors of 8 are 1, 2, and 4. If we like, let's remove 1. Alright? So let's take 2, 3, 4 for 12 and 2 and 4 for 8. So after writing out their factors, we consider the factors of both numbers. Then we pick out the highest common factor. That's the number that is common to both of them. We pick out the highest number that is common to both of them. And in this instance, the number is 4. Right? So the HCF, which is the highest common factor of 12 and 8, is equal to 4. So the next thing we have to do is to look for the second part of 12x plus 8. And to get that part, we have to divide 12x plus 8 by the value 4, or by the number 4. So 4 divided by 12x is 3x. 4 divided by 8 is 2. So now we are going to express 12x plus 8 as a product of these two numbers. In other words, we are going to use 4 to multiply 3x plus 2. Therefore, 12x plus 8 is equal to 4 multiplied by 3x plus 2. Can you see it? So now this is the simplest version of this value here. This is